I'm Craig Berntson. I am the Chief Software Gardener at Mojo Software Works in Salt Lake City. My company helps other companies improve their development practices. So it's not like Agile, but it's improved the processes the developers are using. I've co-author of the book Continuous Integration in .NET, and as of November 1, I will have a column in .NET Curry magazine. If you're not familiar with that, it's published in India. It comes out every 2 months, and it's free. So look up .NET Curry. The content is really good. And I'm Component 1 Community Influencer. And what that means is I use and I really like Component 1 products. They're some of the best widgets, UI controls, and things out there. And in exchange for me putting a slide in here and passing out little cards, they help pay for me to be here. But I wouldn't be saying this if I didn't think they were the best stuff. So at the end, I'll pass out these cards. You can fill them out, and one of you will walk away with $2,200 worth of Component 1 software, and someone else will get this really spiffy .NET Gurus Can Cook apron. So when you're out barbecuing, you can prove that you are not only a cook, but a geek all at the same time. And Russ is head of evangelism back there. He's got me all wired up here. So let's talk about some things that we might be doing in our applications. How many of us have these types of statements in our applications? If, loop, for, while, do while. What's the problems with this stuff? Increases complexity, right? And so what does that mean? How many of us write code and throw it over the wall and some QA person picks it up and tests it? Or even worse, we throw it over the wall and our customer picks it up and starts to test it. The problem with this is, how do you test this? How does that person doing that test know where these statements exist in the code? They can't possibly know that. So how do we know that they're actually testing both paths through this code? There's no way we can. And in fact, it's worse than you think. In 1976, G.J. Myers described a 100-line program that had 10 to the 18th unique paths. 3 years later, he described a much simpler program. It was a loop and a few if statements that you could write in 20 lines of code with 100 trillion paths through the code. Now, granted, these are contrived examples, but I think they help us to see how complex this can get. How many of us have if statements, embedded in if statements, embedded in if statements, and else statements along with them? And now you start to think, how many code paths are there through there, and how complex can that get? And how can we possibly test this? How can we then write the code, throw it over the wall, and hope that someone tests it to make sure it's right? How do we do that? Well, the answer is we have to do that. As developers, we're the only people that know where these code paths are. And that's the purpose of unit tests, is to test that type of stuff out. So today, we're going to talk about setting up our tests. How do we test things? How do we test these code paths through the code? And what can we do to make that happen? We're going to talk about how to remove the database from this. What's the problems of using a database for testing?
It's hard to hit reset.
It's hard to hit reset. Data changes, doesn't it? So we may have different data the second time through those tests. So let's remove that database entirely. And we're going to keep it simple. Anybody doing unit testing right now? Nobody. One, kind of, maybe, somewhat. Okay, we're going to keep it simple. We're going to make it really easy. We're going to start from scratch and build this up step by step slowly. We're not going to talk about test-driven development. I think you have to understand unit testing before you can get into TDD. In the end, they will accomplish the same goal, but what we're going to do is we're going to write the code first and then write the test. So that's test after development. TDD is you write the test and then you write the code to make the test pass. We're not going to talk about JavaScript testing. We're not going to look at production-ready code. We're going to look at contrived examples because they demo better. So let's take a look at our sample, and we'll just do a very quick overview of what MVC is so that you can kind of follow along with what's happening. So what I've done is I have taken the standard MVC internet template, and just added a couple of pages to it. So out of the box, it gives you the blue bar, it gives you all this kind of stuff. So we have a state table, so we can go in and modify states and look at those, and I click on that, and so we can see that we've got some states in there, and those associated with some countries. We can see that if we go into country, here's where we can maintain the country information, add, delete, edit, and so on. We also have a salutation, Mr., Dr., Mrs., etc. And finally, we have some customer information. And this is where the interesting things are going to happen we're going to look at today. So we have two customers in there, Bullwinkle Moose and Lily Munster, and we can go in here and edit Bullwinkle, and we look at this edit screen, and we can see here's our salutation in this drop-down, and so on. The interesting thing here is if we pick a country, say Canada, now this state drop-down populates with the provinces in Canada. You can see that's the only ones exist. If I switch back to the US, we also get whichever states were also in that table. So let's actually go into Visual Studio and look at this project and see what it's doing. And I'll zoom in on this here so you can see it a little bit better. So all I did was I went into Visual Studio, I said create a new MVC project from the template. And from in here, we can see that it's created a number of different folders, app, data, app, start, content, controllers, and so on. With a normal web application, say a standard ASP.NET web application, when you reference a URL in your browser, it goes to a specific page with file on disk with that reference. With MVC, you reference a method in a controller. And it hits the controller takes a bunch of stuff and puts it together to create the HTML page to ship it back to the browser. So the views are where you define what the user is going to see, and it doesn't look like HTML. Let's go into one of these views. Let's pick something really simple, like our customer index page. So let me zoom in on that so you can see it a little bit better. So this is what they call razor syntax. So everywhere that starts with a little @ sign, up here you can see this in yellow, up here. That is where code is going to start, and the MVC framework takes this, combines it with data, which is the model, the M of MVC. This is the view, and then generates the HTML that it ships out to the browser. You can see some of the stuff, and it looks like HTML. We've got paragraphs, we've got tables, and so on. Okay? So that's the MVC. The model is the data, the view is what the user gets, the controller makes it all happen. Let's look at a controller really quickly, and this is actually the one we're going to look at. So we'll zoom in here, and as you can see, it sets up a database context. By default, MVC uses entity framework code first, so context holds all the information you need to access the database. So down here it says, go into the context, go to the customers in that context, which then pulls the customers out of the database, converts it to a list, and sends it to this view method, which pulls out that view we just looked at, ships that off as an action result, and then the framework makes the magic happen of putting the view along with the data and so on, and creating the HTML. So, okay? Real high, quick level of MVC. All right, so this is what we're working with, and we're actually going to work with this index method in our example here today. First thing we have to do when we unit test is have a unit test framework. This handles the running, not the running of the test, but handles the coding of the test. What happens with the test? Kind of think about how you have the .NET framework. This is a unit test framework. It just has classes to make you able to test the code. And there's a number of unit test frameworks out there. MS Test comes with Visual Studio, so it's really easy to get up and running. Another very popular one that's free is NUnit. There's also XUnit, and there are others. So how do you choose which one you want to use? The first way is, are you doing continuous integration? Do you have a build server running of some kind? If you're using TFS, you want to pick MS Test, because MS Test is part of Visual Studio, it's part of TFS. If you're not using that, say you're using TeamCity or one of the other continuous integration servers, you want to pick one of the other tools. Today we're going to use NUnit because I do not use TFS. So we're going to pick NUnit, but you'll see it's very simple to get set up and using. The second thing you need is what's called a test runner. This is a piece of software that actually runs the unit tests. And it so happens there's a test runner for all of these frameworks. MS Test has one, NUnit has one. If you're using ReSharper, it also comes with the test runner that can run either MS Test or NUnit and some of the others. We're going to use another test runner called NCrunch. NCrunch is not free, you have to pay for it, but I think it adds some advantages that we'll see as we go into this. MS Test, as I said, the test runner is part of Visual Studio or TFS, which is why if you're not using those, you don't want to pick MS Test. So when you write unit tests, the typical process you use is you write some code, you write a test, you compile them, then you have to run the test. So you stop the writing process to compile and run. The thing I like about NCrunch is it takes your code, it compiles it in the background on another core of the CPU, so it doesn't really slow you down, and it gives you immediate feedback right inside Visual Studio to see whether that test passed or failed. And we'll see that when we get going here. And I'll point it out so it makes a lot of sense to you when we get there. All right, so let's go ahead and write our first test. So we're going to look at this. We're going to write something on this index method here. All right? We're going to write a test for this index method. So we want to make sure that's doing things correctly. So maybe we want to see what that is returning here. It says db.customers.toList. Maybe we should make sure it's actually returning a list of customers. And it's returning a specific number of customers or all the customers that are in the database. There's a number of things we can do there. So the first thing we want to do is create a new project. If you look down here, I have demo.unittest. This is a new project. I've added the solution. And then I use NuGet to put NUnit references into this unit test. Anybody is not familiar with NuGet? Okay, NuGet is a library up in the cloud of code and components that we can get. And the way you use it is, this probably won't let me because I have no internet connection. You right-click on references, and you can add a NuGet package, and then you can search for what you want. And there's all kinds of really great stuff out there. Some of it's free, some of it's just demo code, some of it's 30-day trials and that sort of thing. I just add it to the unit test. I don't add it to my main project, just to this unit test project. So I've already done that. So, and I've started this customer controller unit tests. So here's going to be our first unit test. The first thing we have to do is reference the NUnit framework. The one nice thing about NuGet is it puts all of the references in for us. So we don't have to add references to some DLL. It does all the work. And if NUnit gets updated, we just right-click, say Update. It just updates it for us. Removes all the old stuff, puts in the new. The next thing we have to do is figure out the name of the class. The name of a unit test class should be what we're testing. A good rule of thumb is one unit test class for each class we're testing against. So we're going to test the customer controller. Then we have to decorate it with this test fixture. This tells NUnit there are tests in this class. Then we're going to create a method that will actually run the test. And in this case, we're always going to return a void on these tests because they never return anything, it just everything internally. The next hardest thing is to decide what the name of this test method should be. It should consist of three things. What am I testing? What are my inputs? And what's my expected output when things work correctly? So in this case, we say index returns action result. Because if remember, back in our controller, it returns an action result. All right? Then each unit test consists of three parts: arrange, act, and assert. So arrange is where we do all the setup, everything that has to happen before we can actually run the code we're testing. In the act, we're actually running the code, and assert validates that we're getting the proper results back or not. So you notice I have this ignore attribute on here. That says ignore this test. So if we were to run all the tests, this one would be ignored. I'm actually going to comment that out. Now you see these black dots over here? Oh wait, that one turned green, little green arrow. See these black dots? That's coming from ncrunch, my unit test runner. And what it says is, in this case, this line of code is written, but it's not really testing anything. I can't find anything for it to test. If we come back to our customer controller, you also see black dots over here. They tell us the same thing. So I'm just going to do a build. And I'm going to come back here, and now we're getting red. That tells us the test didn't pass. We want green dots. Red, green. You've heard of the red-green refactor? This is where the red and green come from. So how do we know the test didn't pass? The X tells us that this is the line of code it failed on. So how come it failed? What's happening? Any ideas?
Throw an exception.
No, didn't throw an exception. Here's the problem. It can't access the database. Didn't we just run this code and it worked? Why can't the unit test run it? Because the unit test is sitting in a DLL. And the DLL has no idea what the connection string is to the database, therefore it can't open the database. So we can solve this in a number of ways. Number one is we can change the output information on that DLL so it saves it to the same folder where the web.config file is. Then it can find it. Number two, we can copy that connection string into a DLL.config file so that it can then find the information. But I like number three. Let's get rid of the database all entirely, right?
It's a unit test.
It's a unit test. Unit test should be in memory. It should run as fast as possible. Technically speaking, if it accesses the database, it's an integration test. So there's a fine line between unit tests and integration tests. The code may look almost exactly the same. It's just, is it accessing the database or not? Or some external component. That's also an integration test. So let's take a quick look back here at this unit test to see what it's testing us. See, we got this red. This is a red circle and it's yellow in the middle, kind of a yellowy. What that does is it says, we think, or I think, I'm ncrunch, and I think that this test is taking too long to run this line of code. That's what the yellow means. And this is where the actual error occurred. Okay. So we can get lots of information without having to run it, look at some other UI to give us the feedback, and stop our process. This will happen in the background as we get going here. So we need to eliminate the database. By default, here's what MVC is doing to access the database. The controller talks to the context. Now, we didn't really see the context. It's part of Entity Framework. Let's come back and look at this context a minute. So if I come over to my project and I open my models folder and come into this context.cs file, we'll zoom that to make sure you can see it. You see this inherits from DB context. DB context is part of Entity Framework, and it kind of provides all the stuff to get the database's connection open and up and running, and kind of a way for all this stuff to happen. You can see I've created some other properties here, customers and salutations, and each one of these is a DB set of some model that I've created, like customer. Let's look at the customer model really quickly. So all I've done here is I've taken every property or every column in the database and created a property for it. So it can hold this information in memory. Instead of using ADO.NET, it's using Entity Framework. And I've decorated it with some things such as display name so that when it displays this on the form, I can say, go out and grab the display name assigned to this property and use that for its prompt. Right? There's other things we can put in here like required. Is it a password so it knows how to mask it when it displays it on the screen? You can even do things like phone number. So it checks to make sure that it's all digits and that sort of thing. There's a bunch of stuff you can do. So this is the actual model for the customer table. So this context is controlling all of that for us. and accessing it. Okay, so the controller talks to the context. The context then talks to the rest of Entity Framework. But because the context is part of Entity Framework, it's very tightly coupled. We need to loosely couple this so that we can inject something in there so it doesn't actually talk to the database. The problem is context is not based on an interface, which is the easiest way to do this. There is no IDB context. So we have to scratch our heads and think about how we're going to do it and maybe go and cry for a little while because it's hard. I'm going to make it easy. We're actually going to remove the database in 3 steps. Number 1 is we're going to replace all of the context and entity framework with something called a repository. It uses the repository pattern that's very commonly used in these scenarios. Number 2, we're actually going to mock. At that point, we actually remove the database from what we're doing. A mock is basically a fake. It's an imaginary instance of something. And the third thing is dependency injection, and that's not really required to remove the database, but it just makes it easier for us so we can write less code to do it. If we write less code, that means we have to maintain less code, which is a good thing. So let's start by talking about repositories. Remember before, the controller talked to the context that talked to Entity Framework. So in step 1, we're going to insert the repository in here. The controller will talk to the repository, which will talk to the context, which will talk to Entity Framework. So not actually removing the database yet, but we're inserting what we need to remove the database. The nice thing is this is going to be based on iRepository class that we're going to have, so it's an interface, and it extrapolates this away from the context, so we won't have to use it. So down here in my models, I have a number of classes. I have an country repository, an customer repository, an state repository, and so on. So let's go ahead and look at this country repository to start with. So actually, let's look at customer, since that's what we're working with. Let's look at customer. It's going to look the same, but we'll look at that one. All right. Public interface, customer repository. So the first thing we have is queryable of customer. The property name was customers. So what this is saying is, if you call repository.customers, it's going to return an queryable list of those customers. We also have a save method and a delete method on here that we're going to use. Okay, that's the entire interface right there that we need for our very simple example. Now we have to implement that interface. So I'm going to go to the EF customer repository class, and I called it EF because it's going to use Entity Framework. Notice here is where I'm referencing the context inside this repository. Here's the customer. So what it's going to do is call to the context and call that customers method on the context and return a list of queryable of customers. If we save, the first thing we're going to do is we'll look to see if customer ID is 0. If it is, we're going to assume that we're adding a new customer. So it's going to add the customer to this customers list. Otherwise, it's going to set the entity state to modify, which tells Entity Framework this entry has been changed. We call the context to save the changes and then return a customer. Why are we going to return a customer here? Because if we add, Entity Framework is automatically going to put that new customer ID in for us. That's one of the hardest things to do, isn't it? What's the idea of this new row I just put in the database? Entity Framework does all that work for us automatically, and we'll get it back in the customer object. And finally, delete just says go and remove the customers and save changes. So step 1, let's just put this in. We haven't removed the database yet, but we have to do this step so we can get to that. So how are we going to implement that? Let's come back to our customer controller. First thing is I'm going to set up a property. And now I have to create a constructor so that we put something on this property. So we're in the customer controller. All right, we have to make that public. And we're going to say customer, let's say this.customer repo equals, and in this case, we want to create just this first step. We're going to point it actually to that entity framework instantiation of it. Step 1. Now down here, instead of calling DB, we're going to say customer repo.customers.toList. So, next question is, will the unit test pass?
No, you're still hitting.
No, we're still using the database. But remember, I said we're going to make this easy and go to step 1 first, step by step. But does this run? If we go to the customer list, do we still get customers? Let's find out. In theory, okay, customer, click on that, and we still do get customers in the list. See that? So we know that it's going out to the repository, to the context, to entity framework, to the database, and back. So far, so good. Step 2, we're going to mock this out. We're going to introduce mocks. So what's going to happen is the controller will now talk to the repository, which will talk to the mock instead of talking to the database. And this allows us to fake the database. The nice thing is, we'll be able to have this eventually have this talk to the database without changing any code. It will know whether it's talking to the database or the mock, or whether it's in entity framework or not. The code won't really know in the controller, but the application will do it. So what will happen is that top line up there is our test path. And if we're running a test, it'll say talk to the controller, talk to the repository, talk to the mock. If not, the controller will then talk to the context entity framework at runtime without changing code. You don't want separate code that doesn't get tested one way or another. First thing we have to have is a mocking framework. Oh, lots of frameworks coming in. How do we get a mocking framework? We NuGet it. Okay? So I've already done that. I've already added some references in here to something called mock, M-O-Q. Mock is actually, you can see it right there. Mock is actually one of the mocking frameworks available. And if you go out and you start to look up on the internet how to do unit testing in MVC, everybody's using mock. Well, I found out about a week ago, about 2 weeks ago, mock is not a very good mocking framework. It's actually one of the slowest out there. So you want to use something different. And there's several others. Pretty much anything else is faster. Okay? But we're going to do it. This is what we're going to use. This is what the demo does. So we're going to use it. Okay. So you notice I've only put that into my unit tests. I don't actually put this into my actual application because it thinks it's still talking to the database as far as it knows. So what I'm going to do here is let's come to my tests, and I'm actually going to comment out these two tests because I have one that's already handling all the mocking, and this saves me time and effort. And actually it's going to test something a little bit different than what we were looking at, but that's okay. So here's our new test. Customer index view contains a list of customer model. So if we look down here, this is saying, are we getting a list of customers? So here's what we have. Our arrange step. Remember, arrange is where we set everything up. I'm going to set up a mock of type I customer repository, and now I'm going to add some stuff to it. I'm going to say whenever you see a request for something called customers. Remember we had that customers method? This says whenever you see a call to a customers method, return instead this stuff here. So what it's going to return is an array that has 3 items in it, and it's going to return it as iQueryable, or as queryable. So it won't go to the database, it'll just return those 3 rows. And because this is of type customer repository, everything will stay working. Right? Then, on our controller, we're going to pass in these mock objects as parameters. So we're going to take those and we're passing them in. Yes, question?
Sorry, if I'm getting ahead of you here, you're taking a sample of the database when you're doing the mocking, or is it bringing in the full database?
No, it's not bringing in any database.
Well, it's echoing it here.
It's echoing it here.
Okay, but if it's not bringing in the full database, how would you know later on if you had an application that was like an order entry details type application that it's going to get the data that's going to make sense?
Then you're going to put both of those in here.
So you have to pick them yourselves, or is it?
No, you create these yourselves. I wrote the code here.
You manually have to build them.
You manually have to, again, you don't want to go to a database, right? Here's the thing. Now you're thinking, I'm going to have 50 tests, and I've got to write this 50 times. Well, it turns out that each of your unit test frameworks has setup code that runs on each test. So you can define some setup code in here. You put an attribute that says setup, or it's some other type verbiage. It might be initialized, something like that, as an attribute on a method. So every test, that gets run. So you don't have to do it once. Again, we're trying to keep it simple for our understanding here. All right. Then we're going to call out, and we're going to get, oh, wait, we've got some red there. Uh-oh. We'll figure that out in a minute. And then we assert we're getting something. So we got to change our constructor to bring these objects in, don't we? Because we're passing in these 3 objects. So let's come back to our customer controller. Let's change this to bring those in. So the first one was type of I, customer repository, customer repo, and I forgot the second one. Was it state? State and then country. So we have to have I state repository for state repo, and I country repository for country repo. And we should probably set up properties for each of those. So private of I state repository and a private of I country repository. And we should probably assign the values there. And I know I could use something like ReSharper to make all of this magic, but I think in a demo it makes everybody go, what the heck did you just did? Because code just appeared out of nowhere, so I won't do that.
So you want to use what you just injected? Or?
I'm not injecting anything yet. I'm mocking it. Right? Now, we don't need it for the index method, but other methods would need these repositories set up.
No, I mean, the stuff you're passing, shouldn't you be setting the repo to what you're passing in?
Oh, thank you. I was wanting to make sure somebody caught that. So this needs to be customer repo, right? And this needs without the new. Thank you. Pair programming, it's great, isn't it? So, at this point, it should be using the repository to run the test. What do we think? Yes? No? Maybe? Don't know? I'm totally lost. What the heck are you talking about? All right, I'm just going to build.
So are you going to have 2 constructors here, or?
Are we going to have 2 constructors here?
You just created the constructor with 3 parameters, right? But the regular procedure calls the constructor without.
Oh, very good. That's where I was going to. Is this is going to have a problem. All right, because entity framework, I mean the actual MVC framework, when you actually run this, isn't going to know about any of this stuff. So that means we have to do this. We have to have two constructors. And this one we actually do have to say new EF customer repository and new state EF state repository and new EF country repository, right? So it'll run. Now what do we think? I think I missed over here on the test one line. Oh, it says test. Test, 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 test. We still got a bug somewhere. We've got something that's not working. Let's look at our error list. Ah, here we go. System.web.mvc action result does not contain a definition for model and no extension method model accepting the first argument type. What does that telling us? Here's what it's telling us. That's in red. It doesn't know anything about that, which tells us that when this is returning something, an action result. And it says, I can't find anything about action, a model property on that action result. So we've got a couple of options. First of all, before we get to our options, we have to understand what an action result is. By default, the MVC framework, when we generate this template, returns an action result. That is a high-level base class. There turns out to be a bunch of other types of classes that are subclasses of this action result. So the first thing we can do is we can take action result and cast that as a view result in our test. Personally, I don't like that. I think that our method should return the most precise object type that it can. So we're going to change this. Instead of an action result, let's return a view result. And because that's a subclass of action result, everything at runtime will stay working. Okay, so I'm going to just change that to view result. Oh, look, we already have green. I did not recompile because NCrunch did it for us. This is why I like NCrunch so much. We got a second thing out of NCrunch with this, and that's something called code coverage. Code coverage shows you which lines of code are being tested and which are not. So immediately, we know all the lines of code in that method are being tested and are passing and are covered by a test. It's not just passing tests, it's any test, passing or failing. Our first test works. It's a success. We're not calling the database. It's sending in the mocking data, and it works. Now, is it going to work at runtime? Should. We can find out really quick. It's loading. Okay, we're going to go into customer, and we should just get stuff on this page. It's loading, and we do. And we actually pull them out of the database this time. Success. We feel good checking the code. Yeah. Yeah, what do you think? Is that great? How complicated was that to actually do? Now that you see it, it's fairly easy. When I had to figure out how to do all this, it wasn't that easy. There was a lot of stuff I had to figure out. Okay, the next thing is we're going to do is we're going to take out some code. And here's my problem. Let's look up at these constructors. Notice how similar they are? Right? And remember we had that salutation table, Mr., Miss, Ms., etc. We don't have any repository set up for that. And that's not in here yet. So what this means is when we add that salutation repository, we've got to put it in here twice. We've got to put once in the default constructor and once in the second one. All right? So I don't want to do that. So we're going to use dependency injection to get around that. So here's how we normally instantiate a class. If class 1 needs to use class 2, it uses a new of class 2, right? It says create a new of class 2. And actually, those become now tightly coupled to each other. With dependency injection, class 1 is going to say, I need an instance of I class 2. But what happens is dependency injection says, I'm not going to give it to you. I'm going to give you class A, which implements I class 2, and that's what you're going to get. But class 1 never knows that. It thinks it has an I class 2. So let's bring this down to a different example. And I found this off of, oh crap, I can't remember, one of the big support websites out there. Somebody says, I need to explain dependency injection to a 5-year-old. And basically, here's the example. Your 5-year-old child is eating lunch and they want something to drink. And you say, okay, Johnny, go over to the refrigerator and get you something to drink. And he goes over and he opens the fridge, and he takes out this jar of mayonnaise and he brings it back and sets it on the table. You say, no, that's not right. So he goes over and opens the fridge, brings out a jar of pickles, and brings over and sets it on the table. Well, you can drink the pickle juice. It may not taste very good, but go ahead. So here's how it works under dependency injection. Okay, Johnny, go to the fridge and get something to drink. And he goes up and he says, fridge, I want something to drink. And boom, a glass of milk drops out. He takes it and goes and gets it. See, it stopped him from getting the mayonnaise and the pickles because he didn't open the door. Now what happens when you walk up to the fridge? Fridge, I want something to drink. Notice you said the exact same words. The fridge injects that and says, oh, you're a grown-up. You're not going to want milk. How about a beer? Boonk! Drops out a nice cold glass of beer for you. What you asked for was exactly the same thing. What class 1 is asking for is something of I class 2. It doesn't know what it's going to get, and it doesn't care. That's dependency injection. It's really great because it allows for loose coupling. You're also going to hear the term inversion of control associated with dependency injection. There's also a thing called an IOC container. That takes care of a lot of the setup and stuff that we're going to manually do, and it just does it automatically for us. Again, we're taking it step by step and easy, taking away some of the mystery. First of all, we need some type of dependency injection framework, and guess how we're going to get it? NuGet. Except this time we're going to put it into our actual project. And up here in references, I have one called Inject. Ninject, N-I-N-J-E-C-T. And this one's free. So once you NuGet that, then you go up and you look up the help file, because in there's some code you have to have for the setup. And that code goes in this app start folder. And we'll reference it from here, but this is supposed to be where you put the code that runs when you start up an MVC application. You actually have to call the code. It doesn't happen by magic. But it's just kind of a way to organize it in one place. And we have this thing called the Inject Controller Factory. And in here, there's a whole bunch of stuff that looks really complicated, and we're not going to worry about any of this stuff here. Because you're going to copy that out of the help file and paste it. That's just the setup code it always needs to get going. What we're interested in is this add bindings down here. So what this add binding stuff tells us is it says, anytime you see a request for iCustomer repository and one is not defined for you to use, then use EF-Customer repository instead. Create an instance of it and use that instead. So far, so good? Pretty simple? All right, step 2 to set this up. We have to go down to this file called global.asax. This is like your startup program for MVC. Okay? This is what gets run when MVC starts up. And in here, zoom this out a little bit. In here, we have this line down here. I'm going to uncomment this line. And all this does is call that other class that we just saw in the other file so that it's in scope and it starts it up. That's it. We're now ready to use inject. Here's what we're going to do with it. We're going to come back to our customer controller, and we're going to get rid of this line of code, or this default constructor, rather. Because we don't need it anymore. Because what it's going to do is it's going to say, if you get a request for iCustomer repository, remember, and it's not defined, it's not set up somewhere else, inject EF customer repository. What do you think? Is it going to work? Is it going to be magic and just work for us? Or what? Let's find out. Well, first of all, we've got green over here. So we know the test is still passing. So we know it's getting the mocked version. All right, so let's run it. Are we getting the real version?
It's all compile time, right? All the inject stuff? It's all compile time?
Yeah. Well, you can make it so it does it at runtime. That's what the IOC container does, is it does a lot of stuff at runtime for you. It goes out and you can find a lot of stuff. Depending on which IOC container you use, there's several of them. Some of them require XML files for that stuff to be defined. Some of them use reflection to go out and find things, depending on how you got it.
So like this demo, there's no performance hit. That's all compile time.
Yeah, it's pretty small. Yeah. So, boom, we went to the database. So what that does is that lets us get away from those almost duplicated lines of code. It just works. It seems like magic, but it's really, really cool. It just works. Okay? And my understanding is in the next session somewhere, I don't know where it is, but there's a session just on dependency injection. But look at your schedule if now you're going to change your minds and go to that one. Our tests are up and running. We did the 3 steps to eliminate the database, right? The last one really didn't eliminate the database. It just makes it so we have less code to write and maintain. What do you think? Is that great stuff? Yeah? Yeah. All right. Okay. All right. Remember when we were in our web page and when we selected the country drop-down, it repopulated the state drop-down based on what country you were picking? It does that by making an AJAX call back to the controller, which goes out to the database, loads the information for that country, and sends it back as JSON. So let's look at how we're going to unit test that. So first of all, let's look at that method. That's all the way down here. So here's that method. It's called getValues. It sends as a parameter the country ID. Right? It goes out to the states, gets the states listed for that country ID, orders it by the name of the state. Then it takes those items, creates a new object with just the state code, which is the abbreviation and the name, uses an allow get, so it uses an HTTP get to grab this information, takes that information, converts it to a list, and sticks that in the data property of the JSON result object, and then sends that back to the page. Then on the page, there's some JavaScript which picks that up and iterates through it and loads the drop-down list. So what do we have to do here to make this testable? Any ideas?
Change the turn value to a JSON result.
Well, we're getting a JSON result back. That's what retval is. It's JSON result. Oh, you say right here. That might be a good idea. We can do it without that, but you're probably right. We probably should. But this thing, we got to get rid of the database, don't we? We're going to use the state repo first of all. All right, so let's look at our unit test. And I'm going to come over here, and I happen to know that all the way down here at the end, I have the unit test set up. I'm just going to uncomment that. I feel like I should be on a cooking show. Let's just take this out of the oven, and it's all done. Okay. So we do our arrange. Remember, we talked, you have to do the arrange. We set up those mocks. This time we're going to mock the states instead of the customers. So I have some states in here, and notice I use multiple countries, 2221. And yes, I know they all have the same ID, but it doesn't matter in this case because we're not looking at the ID. Okay. It calls that customer controller, instantiates it. Then it calls the controller. It says get state values for country 2, which is US. It calls this JavaScript serializer control. So it'll serialize the JavaScript so we can read it. And that exists in the system.web.script.serialization namespace. Okay. Then we actually serialize the result, and then we compare it to this. This is what the JSON string looks like. It's this long string of data. So we take that and we compare it to the actual, which is what we get back. And we say, we assert that those are equal. So what's the result? Pass? No pass. Red or green? Green. We didn't do anything. Remember, ncrunch compiled in the background. It doesn't slow down our coding process. It's already run it and compiled, run and tested. Done. But let's come back to your idea of changing that to JSON result and just see if that works. It should stay working. Ncrunch is working down here. I can see it. Oh, it's done. It works.
When it's a view result, how we can check that it's not only return some view, but it only returns some set of records or whatever?
Ah, very question. So the question is, how can we verify that not only returns a view, but it's a set of records? Let's see. I think I might have that. Let me look and verify that. Right here. All right. So this one says it contains 3 customers. So it should return all the customers. Remember how the query looked like. Right? So here's our 3 customers. We set those up in our mock. We set up our controller. We send this model out and return a list of customers. And then we compare the 3, and their actual .count is 3. It actually is returning all of those. And guess what? It's green, so it passes. Done. So, what's the next steps you need to take? The first thing is you go up and you look at my blog. Because in there, I have an 8 steps, an 8 blog posts, how to go through and test everything in the controller. For example, if you look by default in the controller, when it goes in and if it goes out to try to find something like for delete or for details and it can't find it, it returns an HTTP 404 error. How do you test for that? I show you how to do it. I show you how to do some of these other tests in that series. I even do things like, I'm going to use a view model instead of a model. A view model is a model just for that view. And so what happens is you end up writing a lot of code to say, map everything in this object to everything in that object. So you'd say things like viewModel.customerID equals model.customerID. ViewModel.firstName equals customer.firstName. And then you have to do the one to go back the other way. There's a really great tool out there called AutoMapper. You get it. It does all that for you. Then you want to go out and look for a book called Art of Unit Testing. Please get the 2nd edition, which I believe is not yet actually in print, but if you go to manning.com, you can get the ebook version. That's probably one of the best books on unit testing out there, and it's written for .NET, not for Java. Wait, is there any Java people in here? Okay. All right. Then Udemy.com, the guy that wrote Art of Unit Testing does classes on how to do unit testing, and they recorded one of them, stuck it on Udemy.com. You have to pay for it, but it's good stuff. Next thing is something called katas. Katas are a practice. How many of us practice writing code? The idea of a kata is you learn how to write unit tests. So if you go up and look up kata, you can Google with Bing, find katas, and it has a whole list of things. One of the popular ones to get started with is the prime number kata. So the idea is I'm coming in, it's Monday morning, I'm going to sit down, spend 15 minutes, I'm going to write code to calculate prime numbers, and then I'm going to use unit tests to validate that my code is correct. After 15, 20 minutes, you throw the code away. Tuesday morning, you come in, you sit down, you write code to calculate prime numbers. You write unit tests to validate that it's correct. After 15, 20 minutes, you throw the code away. And you do that until you get tired of writing that code over and over again, or you solve the problem. Then you move on to one of the other katas. There's several of them that are out there. They help you write code. Once you get unit testing figured out, then start worrying about TDD. Okay, so by way of review, we talked about the 3 things a unit test should do: arrange, act, assert. We said that unit tests should be run in memory. They should run as fast as possible. Everything should be done in memory. We looked at repositories and how you can use repositories and mocks to get the database out of the way. Mocks can be used for other things too. I have to rely on a connection to some mainframe. I'm going to mock that I'm really talking to the mainframe, for example. We talked about dependency injection and how they can help you loosely couple components and get away from writing additional code. Okay, so here's my contact information. Look at my blog. There's my Twitter handle and my email address. And as I said, you get Component 1 swag. Somebody's going to get $2,200 worth of Component 1 UI controls. And we also have this really cool .NET Gurus Can Cook apron here.